In this video, I'm going to do page 66, number 7. So in that problem, we have a table of information, the names of workers, and then how much they work per week and their hourly wage rate. And we are asked to determine which of the variables are independent and which variable is independent and which variable is dependent in part A. So for part A, what I really need to ask myself is it the wage rate that determines the quantity of labor per week? Or is it the quantity of labor that determines the wage rate? So in other words, is it the fact that how much you get paid per hour is what determines how many hours you work per week? Or is it that how much you work per week is what determines your hourly wage rate? I want to emphasize here that I'm talking about a wage rate and not your paycheck. So in other words, obviously, let's say, and I've given this example in class, let's say that you work at ShopRite and you get paid a certain hourly wage. So let's say you get paid $12 an hour and you work 25 hours per week. Well, obviously, if you go from working 25 hours to 40 hours per week, your paycheck at the end of that week will have gotten larger. And so your paycheck is dependent on the number of hours that you work. But here we're talking about the wage rate. And so what you would really have to ask is, okay, well, if I'm working 25 hours per week at the rate of $12 per hour, then is it necessarily the case that if I work, say, 40 hours per week, my boss is going to come up to me and say, hey, we're going to pay you $15 an hour instead of $12 an hour. So intuitively, that scenario doesn't seem like a plausible one to me. So to me, it's not that the wage rate, it's not that the quantity of labor is determining the wage rate. This is the scenario where your boss comes up to you and says, hey, since you've worked for 40 hours this week, let me bump up your hourly pay to $15 an hour. That's not a relationship that must happen or intuitively happen. So I'm going to say that it's the wage rate that determines how much you work. So in other words, if a job is paying, say, $12 an hour, you may decide you want to work X amount of hours per week. But if all of a sudden, during, say, one holiday weekend, the boss decides that they want to pay their workers $70 an hour, then I can imagine that the quantity of hours that you work per week is going to increase dramatically. So it's wage rate that's going to determine quantity of labor. That means that the wage rate is our independent variable, and our quantity of labor is our dependent variable. It's being determined by the wage rate. So that's going to be the answer in part A. Now, in part B, we are asked to create a scatter diagram that illustrates the information in the table. And we're told actually to do something somewhat counterintuitive, because we know that our independent variable always goes on the x-axis. And in this problem, actually, they're asking us to put the wage rate on the vertical axis. And this is going to try and prepare us, though I've said in class I don't think it's a very intuitive preparation. Nevertheless, it's trying to prepare us for a situation that we'll encounter later in economics, where price is on the vertical axis and quantity is on the horizontal axis. So we're going to put wage rate on the vertical axis as they've asked, and then we're going to put quantity of labor on the horizontal axis. And we're going to try and plot these points. Now, before I plot these points, I first need to consider, what makes sense to, to sort of organize my axes. So let's first consider the wage rate. I have an hourly wage rate that's spanning from $15 all the way to $75. So I have to think about, do I want to make the difference between my tick marks on the y-axis in terms of, $1. So I start with $1 and then $2 and then $3 and so on. I don't think that that's very feasible, because going from 1 to 75 in a graph isn't exactly the best use of time. Rather, I think I can make this a little bit easier if I make the tick marks in increments of 15, and let me show you why. So let's say this is 15, this is 30, 45, 60, 75. Now notice I've gotten all the way, I've spanned all of the values that I need to plot, and I'm still on the graph. And conveniently, all of my points are going to fall exactly at those tick values. Now let me consider how I want to organize my horizontal axis, my x-axis, the quantity of labor. Well, one of the things to notice here is that I'm spanning, 30 to 37, and so it's a very sort of, it's just a very specific span of hours. So if I made the tick marks in terms of just 1 hour, so 1, 2, 3, 4, notice what's going to happen. First of all, by the time I get to 37, I'm going to be off the page. Second of all of my information is going to be squished between this random, portion in the middle of my graph. So that's not exactly the best representation of the table, of the values in the table. Rather, what I'm going to do is actually truncate my axis. So I'm going to make these 2 tick marks here, which, signify that I am essentially cutting out a portion of the horizontal axis and, sort of sliding it forward towards the origin. And as a result, my first tick mark is going to have a gap from the origin, so that's 0 there, the origin, is going to have a gap that's larger than the gap between the rest of the tick marks. So I'm going to start this off at the lowest value, which is 30. And so there's 30, and I'm going to now make it from, make my tick marks in terms of 1 unit. So 31, 32, 33, and I'm trying as best I can to keep the gaps equidistant, and also to keep the gaps, to allow the gaps to match the gaps on the y-axis. Okay, now let me start plotting my points. So I have that Athena is working at a wage rate of $15 and 30 hours a week. So that would be that point there, and I'll just label it A for Athena. Boris is working 35 hours a week and is getting paid $30 an hour. So there's Boris. Kurt is working 37 hours a week, getting paid $45 an hour. And I'm just, eyeing this up as best as I can. It's not perfect. Diego is working 36 hours per week and getting paid $60 an hour. And then Emily is working 32 hours a week and then getting paid $75 an hour. Oh, that's not exactly even. Okay, let me try that again. Maybe over here. Okay, so that's Emily. Okay, so that's my scatter diagram. And, it's a scatter diagram because every single point that is represented between these 2 axes actually corresponds to, a data point. Now the part B asks me to connect these points with a nonlinear curve. And so I'm going to go from Athena to Emily and just connect them in this way. Okay, so I have this strange looking curve here. Now part C asks me, so let's consider part C. I'm going to come over here. Part C asks me to consider what happens as the wage rate increases from $15 to $30 and to think about how the numbers work to respond to that wage increase. So I'm going to consider, here at A, I have that Athena's being paid $15 an hour and working, so she's being paid $15 an hour working 30 hours per week. Boris is getting paid $30 per hour, so that's the movement I'm asked to consider in this problem, and he is working 35 hours per week. So I have to consider, okay, we've gone from 15 to 30, we've gone up in this way. What has happened to the quantity of labor? And it's gone up, it's increased. So my answer for C is that as the wage rate increases from 15 to 30, the number of hours worked increases. Okay. Now it asks me to calculate the slope, the average slope of the curve between Athena's and Boris's data points using the arc method. So let me explain what the arc method is. The arc method says, so first of all, we have to know that the slope of the curve, and I'm going to do it in green now, from A to B, from Athena to Boris, the slope of this curve, and it is very slight, it does from Athena to Boris, is going to change as we move from A to B. And the reason it's going to change is because the slope at each point between A and B is the slope of the line tangent to that point. So it's the slope of this line here, the slope of this line here, the slope of this line here, of this line here, of this line here, this line here, this line here. Now, each one of these lines, it looks, it's a very faint difference, but nevertheless, each one of these lines has a different slope. And what the arc method tells us is that we can get the average of all of these slopes if we simply join A and B together by a straight line and calculate the slope of that line. So, and how do I calculate the slope? Well, I'm going to calculate it this same old way I've always calculated it. So I'm going to pick 2 points on the line, label them x1, y1, and x2, y2, and then use my slope formula to get the slope. And that slope will be the average slope between the points A and B. So now let me pick my points. So the easiest points for me to pick are just to pick, Athena's point and Boris's point. So for Athena, I have the point 30, 15. She's working 30 hours a week, getting paid $15 an hour. And then Boris is working 35 hours per week and getting paid $30 per hour. And now I am just going to select one of these points to be x1, y1, and it doesn't matter which one I choose to be x1, y1 and x2, y2, as long as I keep the x's and y's together and the ones and the twos together. Okay, and now I can substitute these values into my formula for slope. So number of hours worked increases. Okay, so now I'm into calculating the slope in part C. Okay, so my formula for slope. We've gone over this, is delta y over delta x, where delta is just the Greek the triangle is just the Greek symbol for delta, which means change in. And more specifically, when we talk about change, we're going to say the change in y, y2 minus y1 over x2 minus x1. And from here, it's just about plugging these numbers in. And so for y2, I have the value of 30. For y1, I have the value of 15. x2, I have 35. And then x1, I have 30. Okay? And now, I'm just going to simply add or subtract. So this is 15 over 5, which gives me 3. So the average slope between Athena and Boris's values, is of the curve that joins Athena's and Boris's values is 3. Okay, so in part D, we're going to do the same thing, but we're going to do it for different people. So let me create some room here. Okay, so in part D, we are asked to consider Diego and Emily. Okay, and so they ask us first, as the wage rate goes from 60 to 75. So from 60 to, so let me put this in a different color. So from 60 to 75, then, so it's an increase. Then what happens to the quantity of labor? Well, it goes from 36 to 32, so it decreases. So that would be the answer there. And this is a negative relationship. When one variable goes up, the other goes down. So the answer there is that it's a negative relationship, because when the wage rate goes up, the quantity of labor goes down. I'm just going to put WR for wage rate increases, and I'm going to put QL, quantity of labor, decreases. Okay. Now we are asked to calculate the average slope of the curve between Diego's and Emily's data points. So we're going to do the same thing. Let me just again create some room for us. And let me also, I'm going to fix this curve so that it's actually conducive to our visualizing what it is that we're doing. So I'm going to make this a little bit more curvy. Okay, so this was Diego and this was Emily. Okay, so let's employ the arc method again. Again, the arc method is telling us that it can be used to calculate the average slope between Diego's, so I'm going to circle that now in green, Diego's and Emily's points. What does that mean? Well, along this curve from Diego to Emily, the slope changes, and the slope is represented by the slope of a line tangent to the curve all along here. Okay, and that line just touches that curve in one point. Now the slope of this line is changing. Okay, it's decreasing. It's decreasing from right to left. It's becoming less and less steep. And so what the arc method is going to do is to tell us what the average slope of this curve is from Diego to Emily's points. In order to employ the arc method, or what we want to visualize that we're doing here, is that we're connecting a line from Diego to Emily, and we're saying, okay, what is the slope of this line? The slope of that line will give us the average slope between those 2 points. So again, same as before, I need to delineate what these points, these coordinates are, and then plug them into our formula for slope. So Diego is working 36 hours per week at a wage rate of $75, that he's 60. So 36 hours per week at $60 an hour. And Emily is working 32 hours per week at $75 per hour. Smart girl. Okay, now one of these points is going to be x1, y1. The other is going to be x2, y2. It really does not matter which is which. So I'm randomly picking one for x1, y1, and randomly picking one for x2, y2. And now I'm just going to plug into my formula for slope, which is, again, delta y, Greek symbol, triangle is a Greek symbol for delta, meaning change in. So change in y, which more specifically means y2 minus y1 over x2 minus x1 is equal to. Now it's just a matter of plugging in. So I'm going to have 75 minus 60, that's y1, 60 is y1, x2 is 32, and x1 is 36. So now at this point I have 5 over negative 4. So my slope is negative 5/4. That's the average slope between Diego and Emily's points.